Alright, in this series of problems, we are going to be factoring binomials. And let's just write up an easy binomial. How about x squared minus 25? So bi meaning 2, so there's two terms here. And I can actually rewrite this as x squared minus 5 squared. Okay, so this is the difference of two squares. And you notice that 5 squared obviously is 25. So this is what you got to remember. We're going to factor this. We're going to write an x. Okay, and write another x here. You're going to write a 5, another 5, except this one's going to be minus, and this one is going to be plus. And when we multiply this out, we should get x squared minus 25. Okay, in other words, x times x is x squared, x times 5 is 5x, then minus 5x. Well, obviously those two are going to cancel out. If you have a 5x minus a 5x, that's going to cancel out. Then you have a negative 5 times a positive 5 gives us a negative 25. Okay, so this has been factored. Let's look at another example. Let's say I have y squared, this time minus 121. So I'm going to rewrite this as y squared minus, what are two numbers that you can multiply together at the same number that gives you 121? Well, that would be 11 squared. 11 times 11 is 121. So once again, we have the difference of two squares. So this is y minus 11 times y plus 11. So that has now been factored. Alright, z squared minus 64. So this can be rewritten as z squared minus 8 squared. Whoa, that's not a square. There. 8 squared. So this becomes z minus 8 times z plus 8. Alright. Oops. I always forget to do something there. There's a reason that pops up. 4x squared minus 25y squared. So this one will be a little bit more tricky. So I'll write 2x, right, quantity squared. So this would be 2 squared is 4, and then x squared minus 5y squared. 5 squared is 25, and then that would just be y squared. Alright, now what we're going to want to do is do the same thing as we did previously. Just take this, you're going to write 2x minus 5y times 2x plus 5y, and that's as far as we can go on that. Alright, what about 36z squared minus 49b squared? So I'm going to write this as 6z quantity squared minus 7b quantity squared, and now this would be 6z minus 7b and 6z plus 7b. Alright, and of course you can always test this out by multiplying this, these two polynomials together here. This would be considered to be a polynomial, and this term here is a polynomial, or even a binomial. And if you were to multiply this stuff out, you should get back what we started with. Alright, so let's work a little bit more difficult one here. What about if I have let's say 27 x cubed y minus 12x y cubed. So we have a binomial and we want to factor it. So we look for the largest number that goes into both 27 and 12. And I do believe that is going to be, let's see, that factors 9 times 3, so it looks like 3 is the largest number that goes into both of those. So 3, and we have an x cubed. We have only one x over here, so we're going to factor out an x. We've got a y and 3 y's, so we'll factor out one of the y's. So 3 goes into 27, that's going to be 9 times. Right, we factored 1x out, so we have just 2 left. And we pulled a y out of there, minus. That's going to be a 4. So 3 times 4 is 12. And y squared. Okay. But it looks like that we're going to be able to factor this also. Maybe. And I'm seeing something here I left out. Pull out an x out of there and we have 2 left. Okay. So this is the difference of 2 squares. So this can be rewritten as 3x squared minus 2y squared. And I'm going to go ahead and put parentheses around all that. And we're still rewriting what's outside here. So now we have 3xy times, so we have a 3x and a 2y, so that's going to be 3x minus 2y, and a 3x plus 2y. And that's as far as we can go with that. All right. So let's see here. X minus 3 squared minus 49. So we can rewrite this as x minus 3 squared minus 7 squared. So we just go through the same following steps. We have x minus 3 minus 7, x minus 3, and then plus 7. But we could actually simplify this down to x minus 10 and x plus 4, right? Negative 3 plus 7 would be a positive 4. So that's been completely factored. And I think we'll just leave it right there. Alright, this is going to be something a little different. We have x cubed minus 8. Supposed to be a cube there, a 3. I can rewrite this as x cubed minus 2 cubed. Now what we have here is the difference of 2 cubes. Alright, and there's kind of a formula that you might want to remember. But I think it's best just to see some examples worked out instead of trying to remember formulas. We're going to rewrite x squared. Now you're going to write the opposite of whatever this sign is next. Okay, which is a plus sign. And then we're going to take this number right here and rewrite it to x. And then this is number here. Okay, and then this number here, this is going to always be a plus. And you're going to square this number, this 2 here. So that will be a 4. So that's the difference of 2 cubes squared. And of course, I'll be working some more of those kind of examples coming up. Lots of examples. I know when I was studying math, that's all I wanted to see was lots of examples. we have x cubed plus 1. Now I think all the rest of those we worked a minute ago, or that last one, the difference of two cubes was a minus. This one's a plus this time. So what you're going to do is you rewrite x, and then we're going to rewrite the 1 here. Right, squaring this, whatever this is, we square it, so that's x squared. Remember, you write the opposite of whatever this sign is, so this is going to end up being a minus. Alright, so whatever this sign is, if this is a plus, then this will be a minus. And of course, we're taking this number here, we're putting it here, but we're not going to put a 1 there, so we just put the x, and then this here is going to always be plus, and we square whatever this number is, and 1 squared is just 1. So we are done. Alright, moving right along. Okay. What about if we had y cubed minus 64? So let's write this as the difference of two cubes. This y cubed minus 8 cubed. Or no, I'm sorry, that should be a 4 there. Okay, so that should be 4 cubed. I was still thinking of the difference of two squares. Now we can rewrite this as y minus 4 times y squared. That's the opposite of whatever this sign is what you write here. And then this would be 4y. And this is always a plus, and you square that 4, and you get 16. Okay. Alright, let's see if I can trick you on this one. We have 64x cubed minus 27y cubed. So we're going to write this as the difference of two cubes. So this would be 4x, put that in parentheses, cubed minus 3y, and that would be cubed also. Okay, so we would say 4x minus 3y, put that in parentheses. Now on this part here, it's going to be this guy here squared, so that would be 4x quantity squared. If this is a minus, then we write a plus, and then it would end up being this number here, which would be 3y times this guy, which is 4x, plus, and then we square this piece here, which is 3y squared. 3y quantity squared. Now we're going to want to clean this up. So I'm going to write 4x minus 3y, so that's not changing. This piece here can be rewritten as 16x squared plus 12x y, 3 times 4 is 12, plus 9y squared. And I believe that's as far as we want to go on that. Okay. I got a good one for you. 22x minus 1 cubed minus x plus 5 cubed. So we have the difference here once again of two cubes. So we're going to use the formula. So this piece here, remember, gets written in 2x minus 1, and then minus, I'll start a parentheses, and this is x plus 5. And close off my parentheses. So if I can squeeze all this in here. Let's see, 2x minus 1, quantity squared, and because this is a minus, we're going to write a plus here, and then we write this piece right here, which is x plus 5 times what we've written here, which is 2x minus 1. And then, of course, remember this is always a plus here. And then it's x plus 5 quantity squared. And, of course, we need to sneak in a parentheses right there. Now, I'm not going to multiply all this out and simplify it down. I just wanted to get to that distance. I think that you should know how to be able to distribute this negative across. Right, square this guy, in other words it's 2x minus 1 times 2x minus 1, and add and multiply this together and square that and simplify everything down. So I'm just going to leave it at that. And I believe that's probably enough examples on factoring binomials.